In this project, we looked at the malware detection using hardware performance counters. Our team was the cohort of 4. The people who worked on this team are James Johnson, Nat Nugent, Jaspal Nijar, and Nanetta Pierre. Next slide. Malware has become one of the most common cybersecurity threats that can affect a wide array of organizations, including businesses, government agencies, educational and research institutions, as well as individuals. Moreover, its use has been increasing year by year. For example, there has been more malware created in 2017 and 2018 than the previous 10 years combined. In 2021 alone, 74% of organizations experienced malware activity that spread from one employee to another. Its increased use has led to the exfiltration, manipulation, and deletion of sensitive data, as well as the shutdown of critical systems. For this reason, malware detection is considered an extremely important aspect of cybersecurity and is still researched heavily. In this report, we focused on the detection of malware on systems through the use of hardware performance counters, or HPCs. HPCs count the hardware behavior of an executing program. It has been proposed that HPCs can be used to distinguish between malware and benignware. The hypothesis is that malware and benignware behave vastly differently. If one looks at the hardware performance characteristics of these two types of software, it may be possible to distinguish one from the other. This project evaluates the performance of several different hardware level events and provides an analysis that compares and contrasts these events for malware and benignware. Next slide.
Previous work in malware protection has been lucrative. Companies such as McAfee, Norton, Kaspersky have been built with this purpose. The traditional antivirus approach has been to use pattern matching to detect known bad software. The companies create signatures, commonly known as patterns, of known malware, which are used to scan protected systems for that malware. A problem with this approach is that new malware may not match any currently known signatures. In 2008, DHON first investigated the use of high-performance counters to measure floating point performance. Now, research examines the idea of using these HPCs to measure performance and also incorporate machine learning to detect malware. Next slide.
To ensure consistent results, we decided to have one person from the experiments. As a backup, we installed the VMware with a Ubuntu 20.04 Linux image on all of our machines. The benignware was a word count program written in C++. We had 2 malware programs to test against the benignware. The first malware tested was a worm that replicated directory files until that directory was full. It was written in Python. The second malware was written in C++. It was a malicious version of the benignware that triggered on a certain set of keywords. We installed the perf Linux tool and used it to compare the events of the 3 files. Next slide, please.
Our results indicate that compared to the benignware sample we tested, the malware was more resource intensive. This is evident in the table and graph. For both malwares, every metric recorded by the HPCs was higher than for the benignware, with the exception of bus cycles and cache misses for malware 2. The reason for this discrepancy is likely that malware 2 processes its data multiple times, thereby better utilizing the cache. The worm malware sample in the middle column is a different type of malware and uses vastly more resources than the benignware. Next slide.
In conclusion, with our limited time, we can be able to distinguish the malware from the benignware. In the future, we would like to run the tests on different types of malware and benignware. As we know, the malware could be a worm, a keylogger, or backdoor. Also, we would like to try the performance application programming interface. It's called PAPI with the API for C and C++ in order to catch some more events and easier to use. Also, we would like to run the purge test with some files with a larger size to capture more events. Also, we would like to go to the assembly instruction to change the code to see the malware so it mimic the benignware. Nowadays, the AI and machine learning is applied to many fields. So we would like to include AI and machine learning together with the SPCs to detect malware. Thank you.
Thank you.
Thank
Thank
you.
you.